Okay. Today is March 25th, 2025, and we are wrapping up Module 6 with some of the information that we kind of talked about before. Last time we were together, we talked about the terms and terminology that's associated with the chapter. We've talked about concepts like random access devices, block devices, sequential access devices, and character stream devices as well. Module 6 is about devices and device drivers. We stated that device drivers are um, software that's associated with hardware. Device drivers are really software that allows the kernel to control hardware, and the root of the operating system controls hardware and software. So we talk about hard drive space and what's associated with hard drive space, as well as RAM, and what's associated with RAM, and how the CPU processes information and how data is being stored as well. So a character stream device is a device that transfers data one byte at a time, which is called a character stream device. Device driver installations. Now, it is often said if you're going to buy a hardware device, the way that you install that hardware device is you first download the current drivers because they said most devices, like if you buy a printer, it's probably been sitting on the shelf for a year or more. So when you buy that printer, if you have the latest drivers and you install the latest drivers when you connect the printer, then it's easy to go ahead and just begin working in terms of productivity. Also, sometimes, depending on the environment, if you connect a hardware device, the computer will start looking for drivers. That is not necessarily the case in some environments. You don't want auto run in some environments because you don't want the network to go out, look for drivers, and bring back a virus. So it just depends on how the IT support sets up how devices will act once they're connected to a network. We've talked about input-output controllers. We've talked about, things that allow like the Southbridge chip that allows devices when they're connected to be registered. We've also introduced the term of registers as well. So it says once the driver is loaded, you generally have three options for installation. Your OS's installation utility, you have a plug and play feature, as well as the installation utility provided by the hardware manufacturer. Sometimes they'll give you a disk or they'll tell you to go to their website, as disks have become very obsolete in our current cyberspace. Okay, and let me make this a little larger. F11. All right. So, manufacturer driver installation usually have a CDD DV-ROM, and like I said before, you go to the manufacturer's website to download drivers in most cases these days. Windows driver installation, the easiest way is to install a driver, is to use the plug and play capability to automatically detect the hardware. We talked about that, but that depends upon the network. Sometimes you don't want um, if I have a network and that going out there is going to make me susceptible to a threat or some vulnerability, then I try to avoid what I can. That's called risk avoidance. When you have plug and play, you're going to install a device and device driver. You can install it to any software driver. You can connect the printer to a computer, plug in the printer into a power outlet, and follow any configurations or instructions that may need to be followed. In terms of your computer, Windows has a installation wizard, and that wizard will give you the ability to install devices and drivers as well. It says use the add a new device wizard if Windows doesn't recognize a newly installed hardware. You want to conduct the installation manually as well. And then they brought up Windows 7 and later versions. You open Control Panel and click a device under Hardware and Sound category. Um, you have the ability to use Device Manager as well. You can use Device Manager, and here you can determine the location of the device driver files, check to make sure the device is working properly, and determine if there's a resource conflict for a device. Give me 1 second, which is easy. You can just, at the bottom, you can type device manager, and you can click in the device manager of the control panel. It's always going to ask me for my password. I hope I'm typing this right. I think I did it wrong. Yeah. Uh, Device manager. I wish they would stop. And I understand to make the laptop more sleek, they do that, but uh, I can't do. I don't have admin access, so they're not going to let me do it. But when you can get into your device drivers or device manager, you can actually update certain drivers as well on your computer. This is my job computer. This is what it should look like. This is what I was trying to pull up. Your device manager. All right. And you can update your drivers, even if you have certain antivirus software. That antivirus software, in most cases, has a driver updater, and you can use that driver updater to update your drivers. I do that a lot uh, with my computer. Right. Here's a Windows driver installation prompt where it says Figure 6.3 shows an example of a display driver in Windows 10 that is working properly. This is the prompt that you would get here where you have general driver details, events, and resources. I know it's a little blurry. All right. We talked about interrupt requests before. Interrupt requests is if there's a process that is running in the background and it needs resources or attention, it will send a signal to pin 1 on the CPU, and the CPU will notify the operating system, and the operating system will begin to see if it can allocate resources to that particular process. There's also the ability to do a round robin where the operating system will start going around and automatically checking different different I just got a notice about locking your doors. Sorry. Um and begin checking different processes to make sure that to see if they need attention. You also have an input output address range in memory, and it's reserved for the use by particular devices. This is why we talked about virtual memory quite a bit, because your RAM will hold processes for an allotted time and then move them back to the virtual memory or the paging file as well. When you're installing Windows drivers, there's another prompt where you can view the resources that are being used by a particular driver. Okay, I'll try it again. I don't know why it won't let me use why it won't let me use so let me see if I can do this. Try one more time. Device manager. If it don't work this time, then I know. Yep. All right. It says you are logged on as standard user. You can view device settings in Device Manager, but you must be logged on as an administrator to make changes. So that's a security feature. So I'm able to get in and see all of the different devices that are logged into this particular device. Like you have your universal serial bus, you have your storage controllers. These are the different storage controllers. You have your sound here. And if I wanted to just right click, go to properties, and you can see different information, but I would have to click on a particular driver, look in properties, and then you see general driver details and events. And sometimes you can see if you need to update those drivers as well. Here's the driver details, and these other features are not available to me, so that I can't, go in and do certain things. That's a user access control that they placed on it so that, IT can manage these systems the best that they can. So if I needed drivers updated, it would have to, I would have to submit that request to them. All right. And I kind of just showed this right here of what the driver tab looks like, where you have the driver details, update driver, um, pullback driver, rollback driver. I'm sorry, if you want to roll back to a previous version of the driver as well, and then you can disable as well as uninstall the driver as well. I keep doing that by accident because I'm thinking that I am hitting F11 to get rid of the border. Driver signing. Okay. When it has been verified, a unique digital signature is incorporated into that driver called driver signing. In other words, the driver is now verified. You may get a question on the final exam that asks you about when do you know that you have secure drivers? It's because the drivers have been verified. They've been signed by either Microsoft or some third party company that has a relationship with, if you have a Microsoft computer, or even with Mac as well, that particular drivers are verified. Here says in Windows 10, unsigned drivers are not permitted. You can do them, you can use them. They just a prompt will come up. It'll be a red prompt. Ask you, do you want to use this software or something like that? You can say yes, but now it's at your own risk. Unsigned driver signing helps to ensure that the driver works properly with the device and in conjunction with other devices. We have in Linux driver installation. All right. You have the central portion of the OS or the operating system, which is the kernel, which is where most of the device drivers are loaded. Which reminds me, I need to show this. I believe I showed this to everyone because I know it was a question on one of the exams. So we talked about this, but I just want to bring it up again. The kernel is the root of the operating system, and we talked about kernel rings, or what we call protection rings. Right. So when you have kernel rings, let me go to this right here. Kernel rings basically talk about if there's certain errors or issues that happen in a particular ring, how will that affect the entire computer? So with your kernel being the source of everything, because it controls hardware and software, if you have any errors in whether it's a hardware or software issue in ring zero, your whole computer is going to shut down. Okay. If you have issues in ring one, it's going to really deal with like, with hardware devices and device drivers. Okay. Ring two is going to deal more with storage devices and storing information. Ring three is really for applications. So your applications can stall and the computer will still run because it's not a ring zero issue. Okay. If your hardware freezes up, then we have a problem. So there's many ways to look at it. And that's one of the things that I kind of asked y'all to, I believe I asked you on the midterm to kind of explain kernel rank. So I just wanted to bring that back up once again. Drivers are either in kernel modules, pieces of code that must be linked into the kernel, or loadable modules, pieces of code that are not linked into the kernel but are loaded when the OS is started. And device support in most Unix Linux versions is limited compared to the OSs, to other OSs. In Linux, you have device special files that contains information about input output devices. You have block special files, character special files, and named pipes. Kind of similar to the terms we went over before. Block special files, they manage random access devices that involve handling blocks of data, which are going to be on hard drive and DVD-ROM storage devices, basically. Then you have character files that handle byte by byte streams of data. Okay. Mice, keyboards, printers, and you have name pipes, which are for handling internal communications, such as redirecting files to a monitor. Devices, you have a device directory. Device special files are stored in the device slash dev directory. Um, if Let me see if I can. Well, I'll pull it up on another screen. The different directories that are associated with Linux as well. I think I did it before in a previous class. It says if you need to create a device for a new device, file for a new device, you use the mknod command. To view input-output device special files on your system, you use the ls command to see all of these files in the dev/dev folder. Okay. Uh, and there is some aspects of Linux that we will touch in this course. Not a lot. So that's why we'll probably go to the online JS Linux. And if you need to learn Linux, you can use JS Linux. And you have different versions of Linux, yeah, that you can use. You can use Fedora. Like if I click here, you'll get an instance of Fedora. Does anybody remember what RISC stands for in computing? RISC, reduced instruction set computer or computing. So if you have a CPU and it's a RISC, it has less instructions than a CISC. Complex instruction set. All right. All right. So here's a instance of Linux. Let's see if it has a man page. Click in it. Man, let's give it a minute. It's searching. It does. So you can see that LS stands for list directory contents. Okay. If I wanted to get out of this, I could hit the Q button and that would get me out of there. If I wanted to look further down, I would hit the space bar. So now I can type LS, hit enter, and it's going to give me the files that are on this particular system for Linux. If I do ls space dash L, then you get a long listing. And if you see here at the bottom, I'll make it larger so everyone can see. You see you have a row of information where it says dash RW dash R dash dash R dash dash. So if I can pull up Notepad, I'll explain that very quickly and we'll get back into the lesson. So Linux files and permissions. Okay. So in Linux, you have directories and you have files. Okay. With those directories and files, you have permissions, and permissions are associated with users, groups, and others. Now, when we say others, we're talking about other people that are going to be looking at files and folders. Users would be us. You know, like if I have some files on a Linux system, then they'll be my files. So there are certain permissions that are associated with users. Groups, as if maybe like you're in an accounting group or you're in a special interest group, everybody would be able to have permissions or some sort of permissions to either read, write, or execute with those particular files. And then others may be managers who need to read, write, and execute certain commands or scripts with those particular files. Okay. So that brings up the read. the write, and the execute permissions. Okay. So they're read, write, and execute permissions. What they do, they designate, excuse me, the terms with the first initial. So you'll see R for read, you'll see W for write, and you'll see an X for execute. All right. So these are the actual permissions. Sorry, y'all. These are the actual permissions that are associated with um, what users are able to do, users, groups, and others. Okay. So so this gives us certain permissions with particular files or directories. So going back here, and if you look here at the bottom, you'll see where it says the bench.py, this file right here. The reason why I know it's a file is because typically if it's a directory, the first space will be a D. Okay. So getting back here, so the way file permissions look in Linux, if it's a directory, it will say D, and then the user is the next group. The user's permission would be the next group. So you can have read, write, execute permissions for the user, read, write, execute permissions for the group, and then read, write, execute permissions for others. So I'm going to space this out some, plus it's kind of small. Let me go here, edit, font. Let's go to 18. Go back. So now you can see, so I'm going to space this out, directory. This is users, groups, and others. So if I was to come here, users, users, groups, others. Okay. So when assigning permissions and being able to read Linux files, you can tell if you have a directory because it will look like this. This is a directory. Okay. If it's a file, it's going to have a dash there, then it'll have either read, write, or execute, read, write, or execute, read, write, or execute, and this would be a file. Okay. So if we go back here to this Linux, you can see that these are two files. These two files, because there's no directory denotation at the front of the permissions chain. Okay. So this is how you determine if there's a read, write, or execute file. There's also a numerical way, we call it an octal way, to look at read, write, and execute, because if you have certain permissions, you'll have a 4 as a number, a 2 as the write, and a 1 as the execute. Okay. So all this would here would be 421, 421, or, and I know it seems strange to some, if you add 4 plus 2 plus 1, you get 7, 7, 7. So this is how you can understand permissions in Linux, whether it's a file or it's a directory, and what permissions the user, the group, or others have when they're looking at files or directories. Okay. So if I came upon a particular file and it looked like this, and it had read, read, that means the users only have read permissions, the groups only have read permissions, and the others only have read read permissions. I'm sorry, read permissions. I drank some water. Just so, but I also know that this is a file. So if I had a D here, and then you have RWX, then you have R. This is a directory, but only the user has read, write, and execute permissions, and everyone else can read what's in that particular directory. Okay. So this is how we start to understand permissions, not permissions, but permissions. Okay, so that's just a little tidbit about how you understand Linux files and Linux directories. Then you'll have the users. There's more to it as well. You'll have the users groups. You'll have the size of the file. Then you'll also have the date of the file, if there's been any changes or anything like that, and then the name of the file as well. So that's how you begin to understand files and then dive more. Sorry, thought I shut that off. So then you'll be able to also be able to understand, once you get more into Linux, you'll be able to understand um, how to navigate and how to understand what you're looking at. So when we come back to the lesson, you'll learn that there's certain device files that are held in a certain directory. Okay. And here where they talked about the ls command, this is just a list command. If you wanted to look up certain devices. Okay. So if I wanted to go that particular directory, let's see if there is a device directory there. So to get to a particular directory, I'm just going to tap in like this, cancel. I'm going to tap and I want to type CD. Oh, gotta click in here. CD for change directory. Now I'm going to do slash dev directory. Make sure I got it right. Yep. And there shouldn't be a dev directory there. So it's going to give me CD too many arguments. All right. Because you can't have a space in a name. So um, we don't even know if there's a dev directory. So I'm going to do ls space dash al. This will give me all. And these are all now you see a list of all files. And we're in the current directory right there. And these are all the files in that directory. There are some hidden files that you're not able to see as well. So in this instance, we can't access a device directory because there is no device directory. Okay. And Mac computers or Mac OS driver installations, it's going to be kind of similar. It says when you obtain new hardware, follow these steps. Shut down the OS and turn off the computer. Attach the new hardware. Restart the computer and operating system. Insert the DVD-ROM for the hardware. In this case, in this current state that we're in our current cyberspace, you would download the drivers and install them. Here you would run the installer program and the DVD CD-ROM for that particular hardware. So here's a question here. It says files that are used for handling internal communications, such as redirecting file output, are known as which of the following? Block special files, name pipes, interrupt files, or character special files. Which one do you think it is? And good morning to you all as well. You can type it in the chat. And B is correct. Named pipes. B, named pipes. So let's go back to Linux really quickly. And all right. So I can do this. Let me click back in here and I'll do man space and I'll do the pipe command. That is the pipe command right there. Oh, did I mess up? Nope. I believe it's searching. If you ever get stuck, you hit Control C, takes you out of that particular command. And I don't know why I can't see. Maybe I have to minimize again. There we go. And I want to go to the manual page, but I want to look up the pipe command. Shift. Pipe to, let's try it this way. Pipe. There we go. So you have the pipe or the pipe to or the create pipe. Um, it says it's a unidirectional data channel that can be used for interprocess communication. The array pipe FD is used to return two file descriptors referring to the ends of the pipe. So, in other words, it's a way that we what we use to kind of um, transfer documents, name pipes. So here on it says when you install printers, you can attach using a USB port, but many printers support wireless printing. Many printers have a direct network connect option that lets you place the printer on LAN. I will tell you now, never hit WFPS because it sends a signal out that broadcasts your internet, and hackers will pay attention to WPS. I learned more about that over time because I used to do that. Get a printer, hit the WPS, it starts searching for the internet, and next thing you know, it connects to the internet. But now you have a signal that's currently searching. And if someone's driving through your neighborhood with a sniffer, they're going to get that signal, and then they'll have access to your printer in your network. It's more efficient to use a direct network attached printer rather than a printer attached to a computer or configured for a sharing on a network. In other words, they're just talking about the difference between a peer-to-peer network and a client-server network. You want a printer where everyone has access to it, as opposed to someone with a printer that's attached to their computer. And that just gives the IT personnel more control. The network interface is always on, making the printer always available to network users. And here we go. Once again, you have a device wizard that you can use to install the printers. You also can use plug and play, meaning that as soon as you plug that device in, it'll start looking for drivers for that particular device. Like if you bought a new mouse or a hard or keyboard or a printer, then that computer will look for those particular drivers. If you need to perform a manual installation or to initiate automatic detection and setup, use the Add a Printer option through Control Panel. And this is what this option looks like. Relatively small, but still. Um, With Linux printers, it says when a print job is sent from an application, a print spooler accepts the job, stores it in a print queue until it can be sent to the printer. So last time we looked at the print spooler in Windows, I told you I've had many issues where the job wouldn't go to the printer from my computer, so I had to restart the print spooler. It says most cups or common Unix printing systems configuration files are in the etc slash cups directory. The cups or the common Unix printing system has a daemon and it will usually detect directly connected printers and install them automatically. And for undetected printers, you can edit the printers dot configuration file directly, but it is better to run the printers tool in Fedora Linux as well. And what I was showing you before was just an instance of Fedora. And here's the add a printer in Linux prompt. And Mac, if you want to install printers, similar, use a DVD or some installation device. You can set up a printer using the printers and scanners utility and system preferences, as well as you can determine the types of printers if there's a default or an IP-based printer on the network. It says a network attached printer that uses Internet Printing Protocol, as well as if you want to connect via Windows. And this is what the Add a Printer applet looks like in Windows. I'm sorry, in Apple or Mac OS. So, in summary, that's printing. Says you have to be able to multitask with these systems or using multitasking systems. Your device drivers provide communication services between the physical device and the operating system and applications, as well as most input-output devices operate using three basic components: a controller, a control register, and one or more data registers. Then for your input-output device, they do require the CPU to read and write each byte or word of data from and to the device registers that are called program input output or PIO devices. Most devices can be categorized based on how data is accessed and how much data is accessed. And in summary, the operating system provides generic drivers for your keyboard, mouse, and other standard devices, but it does not support unique features of individual devices. The advantages of device drivers are that they are OS specific for that particular operating system, and new devices can be added easily, as well as you have different procedures for installing different types of devices on your network or your computer. Also, most operating systems include tools for installing printers, such as Add a Device Wizard in Windows, printer printers tool in Fedora Linux, and printers and scanners utility in Mac OS. Stuttering like crazy there. And ladies and gentlemen, that is the rest of module 6. Okay. For module 7, we're talking about storage devices. So there are a number of terms associated with storage devices, such as volatile storage, a type of computer storage that requires constant electric power to maintain its contents, also referred to as short-term storage. RAM is a short-term storage, random access memory. You have non-volatile storage, which is a type of computer storage that is maintained even when the power is off. This is referred to as long-term storage. You have ROM, read-only memory. That is long-term storage. You also have EEPROM and PROM chips, programmable read-only memory, which is sort of like our firmware chips, which are our BIOS and our UEFI chips. You have solid-state drives, type of storage medium that uses flash memory, has no moving parts, requires less power. It's also faster, more shock resistant than a traditional hard disk drive, but it costs more. Yes, it does. You have local storage media with a direct and exclusive connection to the computer system board through a disk controller. You have virtual memory, disk storage used when there's not enough RAM for a particular operation. So that's what your virtual memory is, section of the hard drive that will store files. It depends on the type of storage. We found out the magnetic tape lasts the longest. We do have like CDs and DVDs. They last for a couple years, but they do degrade fast. Um, Flash technology can hold stuff for a while, but it is very sensitive. So if you notice, when companies really want to store something for years, they'll transfer it back to magnetic tape. Okay. And if I was to show you what magnetic tape looks like, this is magnetic tape. So back in the days when we used to listen to tapes, this is the longest storage medium. I still have tapes from when I was a kid. My CDs, I still have a lot of CDs, but I still have some CDs that I made myself will not play anymore because they're either scratched up or they're just worn away. Um, but magnetic tape to capture speech and music, a magnetic videotape, wooden cloud storage. Well, even if you have cloud storage, cloud storage is either it's just going to go to someone's data center or storage data center. And in that storage data center, they're going to either store it to tape or to CD or to something like that. So it's still, or they'll have a running flash um, center as well. Most of our disks, our hard disk drives are just that. They're basically like CDs, but they're versions of magnetic tape. But magnetic tape is the longest. Uh, so to answer that question, what types of storage are used in data centers? Hard disk drives, solid state drives, and tape storage, often as a combination of both. So when we're storing to the cloud, they're still using these. The cloud is just a way that we can save costs where we don't have to buy all this hardware because someone else owns the hardware. Amazon owns the hardware. Microsoft Azure, they own the hardware. You know, Google and Google Cloud, they're storing all our data, either to hard disk drives, solid state drives, or magnetic tape. Really, cloud storage is like another option. Say if we have a loss event here, like a hurricane or a tornado, but I have a storage facility in, like Amazon is storing my stuff in California, and I needed to bring my business back up, I could easily have them give me copies of that information so that I could build my business back up if we had a loss event. So it's like an alternative. This storage is used when there's not enough RAM for a particular operation. That's virtual memory, which is also your paging file. Swap partition is going to be the same thing as your virtual memory. In Linux OS, a separate partition on the disk is set aside exclusively for virtual memory. So it's called a swap partition. Paging file, a system file in Windows used as virtual memory. It is also used to store data produced when the system crashes. Dump data. This is data that is used for troubleshooting. So when you get a crash, like I have a lot of software, that when there's a crash, I'll get a file code. I download that file code and I can send it to the manufacturer of that particular software, and they'll review it and determine if they're going to make some type of update or tell me how to fix the issue. You know, maybe like not running certain programs when you're running this program so that you'll have more resources, but it just depends upon the issue. Direct attached storage devices. These are storage mediums directly connected to the server using it. Um, let me see here. DAS differs from local storage, direct attached storage, that it includes externally connected hard disk drives in an enclosure with a power supply. So, DAS devices. So, these are DAS devices. You can find some of them at uh, Walmart used to sell these. You go to the Walmart. Here are some versions that if you go to the electronics section and you go look for storage devices, you can see these. I want to get these. I need this. So I can just have storage devices as opposed to having all these external storage devices that I have. Sometimes we refer to them as NAS devices as well. As you can see here, you have SAN versus NAS versus DAS. Yeah. Or in this case, here's a visual of a direct attached storage. We have the workstation, you have servers, and then over here to the side, you have a data storage device, which has multiple hard drives. That's like a data center. Okay. Then you have network attached storage devices, a storage device that has an enclosure a power supply, slots for multiple hard drives, a network interface, and a built-in OS tailored for managing shared files. So basically, it's a computer system all to itself. Let's look up NAS devices. That's DAS. Then we look up NAS, network attached storage devices. These are network attached storage devices. And here's one example of a NAS as well. Multiple hard drives, has its own OS, all that stuff like that. And you use it just for storing devices. So it's like a data center for a network. All right. You have disk drives, a physical component with a disk interface connector, such as a SATA or SCSI, and a power connector. So a disk drives are just you know, give you the ability to, um, I'll just pull one up. There's a disk drive for you. We call this a hard disk drive. You have solid state drives, but this is a hard disk drive. All right. Oh, I should also look up SCSI. SCSI was dying at one point, small computer system interface. See, these were old systems that were used with old school printers, and you could daisy chain a number of this is like 80s, 60s, 70s, really 70s, 60s, 80s technology that has made a resurgence over the years. And these are SCSI. This is a SCSI port. This was like old school printers had these SCSI connectors, but this came back over time. All right. Storage appliance, a storage device that has an enclosure, a power supply slots for multiple hard drives. Isn't this all starting to sound the same? A network interface and a built-in OS tailored for managing shared files or folders. It's a storage device. Storage area network or SAN is a storage device that uses high-speed networking technologies to give servers fast access to large amounts of shared disk storage. So a data center, in most cases, won't have their storage in the same place. They may have another building, and this is what I've learned, that has a storage area network. And whenever the data center needs to store information, it uses that other facility to store information there as well. It says to the server OS, the storage a SAN manages appears to be physically attached to the server. You have your logical unit number or LUN is a point to a unit of it points to a unit of storage that could refer to an entire array of disks, a single disk, or just part of a disk. So it's a logical reference point. All right. A partition, a unit of storage that can be formatted with a file system. It is similar to a volume, but is used with basic disks. Remember, we went over the difference between basic and dynamic disks as well. You have advanced technology attachment, or what we call SATA, a common disk interface technology that's inexpensive, fast, and fairly reliable. I'll show you the what a SATA looks like. SATA. You have SATA cables. This can be anywhere from a 7-pin to a 15-pin connector. One is for power, one is for data transfer. But you have SATA connectors on the bottom of the hard drives. All right. These are SATA connectors at the end. There's a PATA, which is really referred to as a Molex connector on the end where it says PATA power. You have a backplane, a connection system that uses a printed circuit board instead of traditional cables to carry signals. Let's do this. Here are backplane connectors. You'll see these in servers quite a bit. Here's a backplane PCB, printed circuit board. That's what PCB stands for. You have serial attached SCSI or SAS, a newer serial form of SCSI with transfer rates up to 12 gigabits per second and higher. SAS is the disk technology of choice for servers and high-end workstations. So we can see a SAS, not that SAS, SCSI. Here we go. This is the new SCSI technology, the SAS SCSI cable. Looks like SATA, but it's not necessarily. All right. You have SCSI small computer system interface. Older parallel bus disk technology still used on some servers, although it has reached its performance limits at 640 megabytes per second for transfer rates. Non-volatile memory express or NVMe used in a lot of routers and servers, as well as switches, a storage interface and protocol for SSDs that uses the PCIe bus, and that stands for Peripheral Component Interconnect Express bus directly. Just to give you a visual, PCIe bus. And here are PCIe buses. You'll see these on most modern motherboards. This is where your graphics cards and other, like adapter cards can be connected. There's another image. My computer don't lock up on me. And it has. There we go. You have RAID. RAID is called Redundant Array of Independent Disks. This is a storage structure setup system that allows you to create what is called redundancy by either making multiple copies of files and data or having a system where you can speed up how much data you can solve because because your goal is to either create redundancy or to eliminate fault tolerance. Now, a fault is anything that's going to cause your system to stop working. So if there's an electrical storm and it causes the power to go out, this is a fault. If there's a virus and it affects your computer, you have to shut systems down. That's a fault. Um, if someone accidentally does something and pulls the power plug out accidentally, that's a fault. Anything that's going to cause a fault, you want redundancy. So if my disks stop working, but I've made a backup copy, that's redundancy. So when it comes to RAID, RAID is a storage scheme or schema that where you can have a disk configuration that uses space on multiple disks to form a single logical volume. Most RAID configurations provide fault tolerance and some enhanced performance. So here's what I'm going to do now. I'm going to go here, RAID explained, and hopefully they don't bring up the bug spray. Let's go to my guy right here.
I start nursing school in September, and before I sent off my application, I ran it through Grammarly. I graduated with my bachelor's and master's.
RAID 0 is all about speed. It contributes nothing to reliability except to actually make it worse. So it involves taking 2 drives or more and actually striping the data across all of the drives. This means you get to keep all of your capacity and you get to have, in theory, with 2 drives, double the read and write performance, but in the event that one of the drives undergoes a hardware failure, you will lose all of the data that was stored on both of the drives. This configuration is only ideal if you're going to be doing very frequent backups or if you are going for the most extreme performance possible, such as running multiple SSDs. RAID 1 is all about reliability. You get the capacity of one of your drives. You get the performance of one of your drives. But you get the redundancy of two drives. That means if one of these two drives I have here fails outright, all of the data will still be there. There's no performance overhead for running RAID 1, so you're still going to get the full performance of the drives, but the more drives you add to a RAID 1, you're always only going to get half the capacity that you would otherwise have. The advantage of RAID 1 is it's extremely safe, so I would trust most important documents to a RAID 1 array. RAID 10 combines what's good about RAID 0 and what's good about RAID 1 into the same thing. So you're taking 4 drives, you're striping these two and striping these two, then you're mirroring these two against these two. So what that means is you get about double the performance of an individual drive, you get double the capacity of an individual drive, but you could lose up to 2 drives in a RAID 10 array without losing any data. This is great where performance is needed, space is needed, but you don't necessarily want to invest in an expensive RAID card solution like this one. There are types of RAID that we haven't covered in this episode, but we will make another one, so there will be an annotation once that's done. You can go ahead and click on that to learn about them, but those are generally reserved for more professional applications. If you are deploying some kind of a RAID configuration, I would definitely recommend posting in the LinusTechTips.com forum and asking for some help, because RAID can be a little bit tricky to set up. Last but not least, RAID is not a substitution for backing up. Redundancy is not the same thing as a backup. Even if you're running a RAID, you are still susceptible to things like viruses or accidental deletion or other human error, so make sure that you're doing regular backups. Thanks for checking out this episode of Fast as Possible. Make sure you subscribe to TechQuickie and also like the video. It helps us out a lot. Share this video with anyone who you think would benefit from it, including embedding it on your website. Consider this my go-ahead to, well, go ahead. Also, if you can think of any other Fast as Possible episodes that you'd like to see, click the link in the description to post in the forum thread. We will.
Okay. All right. So that's RAID, and there are different forms of RAID. There's RAID 0, RAID 1, RAID 5, RAID 6, RAID 1 plus 0, and we'll cover those at some juncture. Like now, RAID 0, a volume that extends across 2 or more dynamic disks, but data is written to all disks in the volume equally. It provides no fault tolerance, but does provide a performance advantage over simple, or what we call spanned volumes. You have a spanned volume, a volume that extends across 2 or more physical disks. For example, basically it's having 2 hard drives and you group the hard drives as one. So you span, so you can store information on the second hard drive and it's still like you have one hard drive because you're basically connecting 2 hard drives together. You have RAID 1, a volume that uses space from 2 dynamic disks. You need a minimum of 2 disks. And it provides fault tolerance because the same data that's written to one disk is also written to the second disk. So if the first disk goes bad, you still have a backup copy. All right? You have a simple volume, a volume that usually resides on a single basic or dynamic disk. So if you have one disk, that's a simple volume. All right, RAID 5. RAID 5 uses a concept that's called parity. Let me show you an image. RAID 5. Show you an image of RAID 5. I'll use this one. Well, all right, let's go to RAID 5. All right, so here's RAID 5. All right, so you have 4 disks, but you need at least a minimum of 3. With these 4 disks, data is striped across the disks. As you see, I have block 1. Next disk has block 1B, block 1C. Then you have a parity block, and that parity block is going to be used in case any disk that goes bad, all you have to do is replace or what we call hot swap the hard drive. So if you hear grinding, if you hear something going bad, you just take that drive out, replace it with another drive, and the parity bits of each drive will recreate the data on that particular drive. Okay, so this is parity. And I guess for you to understand that, you'd have to understand what parity is in computing. Parity in RAID, right? So in RAID, or redundant array of independent disks, parity refers to a technique of error checking and fault tolerance that uses additional data, which is called parity data, to reconstruct lost data if a drive fails. I often tell people it's like DNA, or like when you look at movies like The Terminator or Deadpool. Chop his arm off, it grows back. It's kind of like that. So you can reconstruct lost data if a drive fails, allowing for data protection and integrity, because it will reconstruct that data if the drive goes bad. All right. You have a boot volume. What is a boot volume? It's the volume basically where the kernel and the operating system are going to be located. It's usually the C drive, but this location is not mandatory. The boot volume is referred to as the boot partition. You have a system volume, a volume that contains files a computer needs to find and load the Windows operating system. We refer to these as the MBR. So you have a volume that has the master boot record or that has the GPT, the globally unique identifying partition table, or the GPT. Some people call it the GUID partition table. What is thin provisioning? A method of creating virtual disks in which the virtual disk expands dynamically and uses space from the storage pool as needed until it reaches the specified maximum sizes. So you can have a group of disks together, you can create a storage space, and then the virtual memory in that disk will basically expand if need be. Just a bunch of disks. What is this? A disk arrangement in which two or more disks are abstracted to appear as a single disk to the operating system, but aren't arranged in any specific RAID configuration. It's just a bunch of disks. It acts like RAID, but it's not RAID. Your primary partition, this will be a disk drive on a basic disk used to create a volume. It is assigned a drive letter, and it will be marked as active and contain the Windows system volume. So basically, your primary partition is also called an active partition, and it will help you define, and basically it has the operating system there. Primary partition. All right. Hard disk partition, where the operating system can be installed and is the only partition that can be set as active for booting. And this is in a legacy BIOS, not in a UEFI. Here's some images of a primary partition, if it will allow me. Here's one such graphic here. Get clear. Well, you have the primary partition here, where you have your C drive, you have your system restore drive, and you have your new volume. Then you have an extended partition here. So we can also look at it. Do I really want to go into this? Yeah, I'll do it. Not how to create a partition, explain primary partition. Oh, we got our guy again.
It's not what's next, it's where.
So back in the time of the dinosaurs, it was pretty much a necessity to partition or divide up your drives, especially if you were running a higher capacity drive on an old operating system such as Windows 95. And believe me, having to deal with like 12 partitions because of file system limitations was kind of a drag. Nowadays, though, with everyone on a Windows-based PC anyway using NTFS, partitioning is no longer necessary, but it can be a valuable tool. So what exactly then is partitioning, and why is it still relevant when we can just dump everything onto one giant 8 terabyte drive and be done with it? Well, Partitioning means splitting one physical hard drive or SSD into several different logical drives or volumes that your operating system will treat as if they were completely separate physical drives. Each volume on a partitioned disk has its own drive letter, like C or D or Z, and folder structure, and can also be formatted, even with different file systems, without affecting your other partitions at all. So if you're just rocking one drive in your system, partitioning allows you some pretty cool functionality. You could set up a hidden partition with no drive letter assigned, so non-tech savvy roommates won't be able to find a particular virtual drive. Many PC manufacturers include recovery partitions that are hidden away and have all of your operating system and drivers and pre-installed applications there ready for you to say, hey, I'm ready to restore my PC. Or if you wanted to dual boot your system. Very useful if you wanted to try out Linux or run a previous version of Windows for improved compatibility without installing a whole new physical disk or getting rid of your more modern operating system. Multiple partitions can also help keep your data safe if something happens to your OS installation. One popular way to do this is to put your personal files and data on a separate partition, so if your OS gets corrupted or infected with certain types of malware, you can just wipe it and do a clean reinstall without also nuking your important stuff. Though it should be noted, this does nothing to protect that data from a physical drive failure. Partitions can also help, though, with a slow mechanical drive through a technique called short stroking. You see, because of the way that hard drive platters spin, the read or write head in your hard drive actually accesses data near the outer portion of the disk more quickly. Short stroking involves creating a partition that only takes up the faster outer portion of the platter. Not a bad place to install programs that you need to access quickly if you don't have room or you can't afford an SSD upgrade. So how do you create a partition then? Well, there's a wide variety of ways. You can actually specify multiple partition sizes when you're installing operating systems such as Windows. From within Windows, you can use disk management to actually shrink and expand volumes, which allows you to partition the space that is no longer being taken up by a volume. You can buy dedicated tools such as Paragon Hard Disk Manager. That's the one that we use around here at the office whenever we have to work with partitions. Or I'm sure that the comments are going to be full of everyone's favorite open source partition management software, and you can check out the most upvoted ones there as well. But there are downsides to partitioning. For one, because of file system overhead, splitting your disk into multiple partitions results in lower overall capacity than if you just had one big partition. You also have to configure Windows to store your data intelligently on a secondary partition, unless you want to just be manually moving things around. And the same goes for programs, because installing programs in one volume and then trying to move them over to another one is pretty much not a thing, meaning that even if the idea was to save yourself from OS corruption, if you're installing a bunch of programs to that other drive, you're actually going to have to go clean them out manually and reinstall them anyway. But if you're the type of person that appreciates fine-tuning and tinkering, and you want your data backups there, and you want to put your managed files there, then don't be afraid of partitions. I mean, after all, where would we be without partitions in public bathrooms? I don't even want to imagine that kind of world. You know what other kind of world I don't want to imagine? One without Squarespace. Squarespace lets normal people like you build a simple, powerful, beautiful website the way you should. They offer 24/7 tech support via live chat and email. It's only $8 a month to start, and you get a free domain if you buy Squarespace for the year. All their gorgeous templates.
I was laughing. I had to stop it. Squarespace. All right, so that's drive partitions. Okay. I'll try to post this up soon. I know I keep saying it. I have like 4 lessons to post up, including this one. Let's go here. What is a VHD file or a virtual hard disk? Basically, when you're using virtualization, for any, like in virtualization just means that you can put two operating systems on a hard drive. So if you're going to use one operating system as a virtualized hard drive, virtualized operating system, it's going to need its own hard drive. So you're going to use a portion of the hard drive or partition the hard drive in order for that virtualized system to have a hard drive. So we just learned about partitions, which is dividing the drives. So we're just going to make a partition that's going to be associated with the virtualized operating system and give it a space for a hard drive. So, in other words, the format the virtual machine running in Hyper-V uses for their virtual disk. Now, Hyper-V is the virtualization software that's really associated with Windows devices. So, a virtual hard disk drive files can also be created and mounted with a disk management, with disk management, and used like a physical hard disk drive. So let's go into that. VDH. VHD explain. I did not say VHS. Guess I have to spell it out. Maybe if I spell explained right. Look for a small one, not a long one. Oh, you just did disk partitions, but virtual hard disk image format. I don't think this one's going to be good, but we're going to try.
With the complete digital marketing course on Udemy, you'll gain skills and knowledge in market research.
Hey guys, welcome back to our channel Technology. So I'm fine, I hope you guys are also doing well. So today I'm going to talk about VHD, which is also known as virtual hard drive. That means you can create a hard drive virtually on your PC. Suppose if you have a multiple volume, means physical volume on your computer, and if you don't want to create another physical volume for your PC, then this method will help you out. So if you create a multiple volume for your PC, then might be it will affect, means damage your hard drive. So for that you can create a VHD which is saved as a file and give you one simple volume for you. Also you can install operating system under that VHD. To create this VHD you need to follow me and don't forget to subscribe my channel Technology. So at first you need to right click on your start menu and you will get this menu. So just right click on that start menu and you will get this menu, and after that you have to go to computer management or desk management. So after that click on desk management. Once you have clicked on desk management you will get this window. Now as you can see, here is my all the volume is showing over there, and also if I'll show to my computer, as you can see here is all the volume is showing over there. So now what I have to do is I need to go to action and click on create VHD. Now here you need to browse this location where you need to save your VHD file. In my case I will save under the F drive, so I will type the name like Technology here, VHD, and click on save. And here you can select your virtual hard drive size. In this case you can select as a MB, GB or TB. So I will select here GB and I will make a 100 GB partition. Okay. And after that you can select here VHD or VHDX. Suppose if you want to create a less than 2040 GB size, then you can select this option which is VHD. If you want to create more than that, you can select this option which is VHDX. So currently my requirement is VHD. Okay, and from here you can select a fixed size, like in future you cannot change your volume size. And if you select dynamically expanding, that means it will expand as per your requirement. Okay, and after that click on OK. So now as you can see, one disk 3 is created successfully. So you have to right click over there on this disk 3 and click on initialize disk, and after that from here you can select GPD or MBR. So I will suggest you to create a MBR. and after that click on OK. Now as you can see, one unallocated partition is created successfully, and here it's not showing any new volume. So what I have to do is I have to right click on this unallocated partition and click on new volume, new simple volume, and click on next, then next. You can select here later, volume later, and after that next, and you can type your volume name, okay, from here, and after that I will type here VHD and click on next, and after click on finish, as you can see, one volume will be added on my computer. As you can see here, it is 100 GB partition is created successfully. So if you want to detach this VHD from here, then just simply right click over there and you have to delete this volume, and after that you have to detach the VHD from here, and it will detach from here. Okay, so I hope this small video will really help for you, and please don't forget to click on the subscribe button, like button and share button, and if you have any questions or questions, then comments down below. I will see you guys on the next video. Take care.
Let's get back into it. All right, so that's virtual disk, a storage pool. What's a storage pool? A collection of physical disks from which virtual disks and volumes are created and assigned dynamically. Collection of physical disks from which virtual disks and volumes are created and assigned dynamically. A storage pool. You have storage layouts. One of three methods used to create a virtual disk with storage spaces. The three methods include simple, mirror, or parity. As you saw the video talking about virtual, let's look up storage spaces. What is a storage space? Let's see. I don't know how that's going to be. That's 10 minutes. Let's try this one. It's 3 minutes. Let's see.
In this video that's entitled Understanding Storage Spaces, I'm going to tell you about a new functionality that's being introduced in Windows Server 2012. And this thing is really getting a lot of positive press out there from the bloggers, out there from the administrators on the forum boards. This is some really neat stuff. Now, really what this is, the best way to describe it is a new way to think about storage organization in a Windows environment. Many of the features that you'll see here were previously only available in enterprise class storage situations, and you can translate that to mean very expensive. So let's take a look at some basics here. First of all, the main thing that storage spaces does is it allows us to combine storage space from multiple drives into what's called storage pools. Now, we can use drives such as SATA, SCSI, iSCSI, SAS, USB. So we can grab chunks of free space on all these different kinds of drives, and then storage space is going to create that as a pool. And the pools are what we use to create what we really see as the storage spaces. And so we go to all these different types of drives, we grab all this space, and then we take that pool and we can combine it with other pools and we create a storage space. And this appears to the end user as a logical disk, like a drive M. And so the user just hits drive M, saves their data, retrieves their data, everybody's happy. But in the background, storage spaces is managing this whole operation. Now, storage spaces offers several resiliency options. Resiliency is another fancy word that Microsoft's using now for what we used to know as fault tolerance. Now, the first option is two-way mirroring. This is what we've always known as mirroring. It requires at least two physical disks, and we just place a copy of the data on each drive every time we save a file. It's automatically done for us, So we have two identical disks with two identical bits of information at the end of the saving session. Now with three-way mirroring, this is kind of interesting. It requires at least 5 physical disks, and storage spaces will place a copy of data on 3 of the 5 disks. And so down the road, we lose a disk, it can reconstruct the data. Then the last one that we have here on the resiliency options is parity mode. This is what a lot of us have become familiar with as RAID 5. And this requires at least 3 disks. It's going to store parity and data on each disk. And so if we lose a disk, it can read the parity from the other 2 disks to reconstruct what's missing on the disk that's gone bad. Now that's the basics of storage spaces. And understand it's going to do a whole lot more for us in the background. But we're going to talk about that in a separate video entitled Storage Spaces and Thin Provisioning. And this gets pretty wild. Okay, so join me in Storage Spaces and Thin Provisioning to kind of continue this. But for now, I just want you to understand the very basics about what storage spaces is. And then you'll see as we move through the course here what it does. And I would strongly recommend, since this is such a new technology and Microsoft's going to be so very proud of it, that you go out and read about this before you go sit this exam.
All right, we're back. So that's storage spaces. You have cloud storage paradigm in which the individual or company storage is hosted by a third party and accessed over the internet. We talked about that as well. That you're so basically that's like a cloud storage is like if I'm storing all your information and every time you have some information you want to store, I have all of the data hardware and software for you to just send it to me and I store it for you. And whenever you want to access it, you can access it through your phone or go online, but everything is stored at my facility. That's cloud storage. So the third party is going to host the storage over the internet. Logical volume manager, a method of creating logical volumes in Linux that uses physical disk partitions called volume groups. Digital linear tape, a tape system that uses half-inch magnetic tapes and has a capacity of up to 1.6 terabytes. Digital audio tape or a DAT. People used to record off this, back in the 90s and the early 2000s, they had DAT tapes. So when you would go to a performance, there was a tape recorder in the back and they would play those tapes and the people would kind of dance and rap to it. Sometimes people would bring their entire vocals, not just the instrumental, and then they would be lip syncing on stage, like Milli Vanilli. So a lot of rap groups do that today, but they don't use DAT tapes. Now you just have someone pull it up on the mixer, but it was a tape. And then you had storage tiering, a feature of storage spaces that combines the speed of SSDs with the low cost and high capacity of hard disk drives to create high performance. So now instead of using hard disk drives, you're going to use groups of solid state drives. Then you have super digital linear tape, a tape system that uses both magnetic and optical recording, which would be like DVDs, and a high capacity tape, which has a tape capacity of up to 2.4 terabytes. Then we just did this storage layout. We did this already. It said C storage spaces. This is when they start giving you some of the same definitions again. And then you have intelligent tape, or IAT, or AIT, excuse me, a tape drive that has an erasable memory chip and a capacity of up to 1.3 terabytes. That's still a lot for tape. I remember having a cassette. Goodness. Solid state drives, a type of storage medium that uses flash memory, has no moving parts, requires less power than a traditional hard disk drive. We went over this already. Linear tape open, or LTO, a tape drive used in high-end servers. It has a storage capacity up to 30 terabytes. That's a lot of information to be stored. And ladies and gentlemen, that is our terms for this chapter. Do we have any questions in regards of the content? If you have questions, you can place them in the chat. Let me go here for 1 second. I just want to see if I need to adjust the dates of the assignments for chapter 7. All right. Is there anyone else on YouTube you recommend besides Professor Messer? Yeah, you have a lot of people. You have Mike Myers. You have Dan's courses, but that's more networking. Dan's courses. I learned a lot off Dan courses as well as Mike Myers. Dan's courses, Mike Myers. Who else would I recommend? Certified Breakfast. Um, there's some good people. If you really want to get into start, I know it's a lot, but if you want to start learning about like hacking and stuff like that, Hackersploit is someone good to try as well. So I put their names in the chat right there. Jason Dion is another. Jason Dion. People really like Jason Dion as well. So those are some names of some good people to peruse while you're on the internet. All right. No problem at all. So, ladies and gentlemen, if there are no questions, then I'm going to go ahead and dismiss class. Let me go here and see if I need to change these dates. The 23rd, I'm going to change these dates for these cases. I'm going to push everything back a week. Okay. This midterm, we did that already. Yep. I'll push everything back a week so it'll make more sense to be able to complete them. Okay. I'm going to stop recording here. No problem.